Yes, sir.
Okay. Share my screen. Is the screen visible? Can you see the full screen?
So,
Okay. So in the last class we have discussed about cohesion. Now we'll see the different types of coupling. So there are 5 different types of coupling. Um, so that is data, stamp, control, common, and content. So I can recall. I mean, I can review once more. Like what is coupling? Coupling means the degree of dependency among different modules. Okay, I mean how two different modules are related with each other. That is called basically the coupling. And lower the coupling, better will be the design. So in this diagram, you see that content one is very high coupling, and data coupling is very low degree coupling. So we always encourage low degree coupling or low coupling. Okay. So now let's see what is data coupling. So how two data they are called data coupling. So I mean they're very loose type of coupling. How they're happening that if two modules they communicate via a, I mean modules means in the inside modules there are set of functions which are there, and then there are some functions which are having a kind of a, they are accessing or using the same parameter. Okay, say function 1 in module 1 and function 5 in module 2, they are using the same parameter. So if this is the case, then that is they're basically called data coupling, means they are depending on a common data between these two modules. Okay, so through which only they basically the communicate with each other, or in other way you can say like the I mean the they have a common parameter or common attribute which they are taking as an input through their function. Okay, or they can communicate, means one same data they are passing produced by one function and to be used by another function. So in this case you see uh, this is module 1 m1. Okay, and this is say m5, module m5. Okay, there is a function called f. Okay, f, and there is a function called say t. Okay, now if both of them are communicating via a common variable x, is say they are x, they either f is produced by I mean the x is produced by f and that x is going to be taken up by t, or both of them are taking the x variable as parameter. Okay, so that if this is the case, then we call it that the module m1 and m5 are actually coupled through data item. Okay, and data item can be integer, a float, or a character, whatever it is. Okay, but it's a very preliminary data item. Okay, they're elementary or preliminary data items or data type data that they are exchanging. Okay. Uh, and another important thing is that there are two things that we want to see. That data is the x is not going to be a control variable. What is control variable? If you are passing a flag, say flag, you know you when you are writing program several times you are using flag. Say flag 1 or flag 0. If flag 1 is, if flag is 0, then do this. If flag is 1, then do this. So such kind of, these are basically called control variables. Flag type variables are called control variables. So in this data coupling, this is not for the control variable. That means control means you are passing some signal from one module to the other module. No data. Other than that, no data. Data means only one or zero, say that flag one or flag one or flag zero. But here in this case, data coupling, they don't consider that control variable. They consider only the data variable. That means it's containing any particular variable. It's not only the control. Then what is next? Stamp couple. See, in the previous case, they are basically the elementary values, means some integer, single value, some integer, some float, some character, or something like that. A bit more advanced is that if it is some kind of structure. Okay, so in case of C, okay, if you have some kind of record in some variable, that means it's a kind of a composite data item. That means collection of homogeneous or heterogeneous data. Okay, so that means it's not a single variable value. It may be a collection of values. So if two modules in the same way are communicating by transferring or taking the same, accessing the same record, okay, same record or structure, then we call it as a stump coupling. Okay, well, first one is for single preliminary data item, elementary data item, only single value. And stump coupling, it's basically a collection of data or collection of homogeneous, heterogeneous, whatever, like structure in C or records or anything in other programming languages. Okay. Now, what is control coupling? Control coupling means that this is the thing that I have talked about during your what is called your data coupling. So control coupling means you are passing some signal, some values through which the other function will going to execute. Okay. So that means output or signal or control signal from one module to the other module you are passing. Okay, just keep in mind that module is basically a set of functions. So there may be n number of modules which are there, and inside that there may be m number of functions which are there. Now the communications happening between module to module, communication happening between means communication happening between module to module is basically the whenever we are drawing like that, say in a structure chart, if you are drawing like that, that's, so this is M1, this is M2, this is M3. So in that case, they are not directly they are not communicating. Who are communicating? There may be some set of functions which are there. If you can remember, there may be a set of functions which are there inside a module. Okay, those functions, those procedures are actually communicating, and if they communicate with each other, if there is any dependency, say, then we will say that this particular module M1 is depending on M2. Okay, so M1 is depending on M2. It's not that module to module communication happening, it's basically the function to function which is happening. If there is dependency between any two functions between two different modules, then we'll say that these two modules are connected with each other or dependent on each other. Now in case of control coupling, okay, so so you say one function, so let us assume that you are using from one module that prime number check. Okay, so what you will do, you will basically say M1 needs a prime number, and then only it will work. But M1 doesn't have the function prime number. So what it will do, it will take that value, okay, and then what it will do, it will call that function from M2, where M2 is, there is a function called is prime. Now what will happen? M2 will going to return back, say flag 0 or 1. 0 means it's not a prime, 1 means it's a prime number. Now what will happen, based on that value that M2 function, that is prime, is returning, then M1 will going to take a decision. So that means M1 will going to wait for M2's function to return that particular control value. So if such a way, if two modules are connected with each other, then we called it as that it's basically control coupling. Okay. Now what is common coupling? Common coupling means if two modules are accessing the same global data. Okay, if they are sharing the same global data, then we call it as a what is called uh, common coupling. So function, there are two functions, and say there is a global array you have declared. Okay, some global array, some records are there. So both the functions from both the modules are accessing that particular common array. Okay, common array. So that way, basically, they are connected with each other or dependent on each other, because they are, both of them are actually accessing the data, because it's very important, because say this particular module, it is updating at the same time. I mean that this particular module cannot access. Okay, because that you know that if you have studied already that what is called shared memory concept in operating system and all. I think you have this time operating system, am I right? Operating system already done, or this is in this semester?
Done, sir.
Done. Okay, fine. So you know that what is called shared memory. So you know these are critical section. So if one function is using that particular one, then other need to wait for that. The other need to wait for that, because you know all those things that semaphore and all read write operations cannot be done simultaneously. So you know all those things. So if this is the situation arises, then two modules somewhere connected with each other, they are dependent on each other. How? That if one is accessing, then other need to wait. Okay. So if it is the write operation, read operation, both of them can access. So if this way two modules are connected with each other or dependent on each other, then we'll call it as basically a common coupling. Okay. That is, they're sharing the global data, global variable. Now, content coupling is the worst type of coupling. What is that content coupling is? Means this is very bad type of programming, which is completely unrealistic and usually never happen. What is content coupling? The code which are there in two different modules, okay, two different modules are related with each other. Say how it is happening. There are two different modules, okay, and there are some function inside that, say f, and there are some function called t. Okay, now what happens from here, from the body, of functions, you are basically going to another functions body. Say from here you can use, say, go to, you have go to, where you are sending level which is mentioned over here, level 5. Go to level 5. So level 5 which is there in module 2. It is this is module 1 and this one is module 2. So this is module 2 and this is module 1. Now what happens? You are jumping from this mean of the function to the another functions part. So that means somewhere they are sharing the code. Okay. To complete that if it needs to take the code which are written inside t, function t. So that means they're sharing some code. So that means they're sharing the content. Okay. So if this is there some way, then it is called content coupling. And you know these kind of jump statement, these are called jump statement or go to statements, are as far as possible avoided in C program, though it is there. But if it is there, but other programming language you cannot get that thing. But C having all the freedom, so you can use it. But if some way you may did it like that, then that basically going to be called content coupling, and this is the worst type of coupling. Okay, the worst type of coupling, because two functions are very highly coupled with each other. Other you see, say for example, this common coupling, it's always not going to be there. Like they need to be dependent. Why? Because both the functions from module 1 and module 2, they are not accessing directly that function. Whenever there are some case situation arises that they need to access, then in that case, then one will have to wait. That is the only case. But it's not always that every time they'll access same time, same time. So that means the coupling is relatively less. But see here in this case, content coupling. content coupling means to complete function F, they need to take the help of function T. Okay, so that is highly they are dependent with each other. Okay, you cannot complete F, or you cannot the module M1 always be dependent on module 2. So that type of coupling is very tight coupling, and this is discouraged in a good program design or software design. Okay. Now we have discussed also this neat structure, clean structure. So whenever we need to represent this high level design, high level design means the modules and the relationship between them. So what is called that's basically we all already represent them as a program structure or hierarchical structure or in the form of a tree structure. Okay, tree structure we call it as structure chart. Okay, so that we have seen these things that it should be in layered form. Okay, there should be very less dependency with its previous how I mean higher level I mean lower level modules. Okay, so that sorry, higher level modules. So that thing you have to I mean if it can be taken care in case of neat or clean design. Okay, that also we have discussed that in a neat management it should have a low fan out and abstraction. So let's study a bit more in detail way that this go fan out and yeah. So and then for any module structure, there are few things that I mean people normally consider. One is called the depth because it's a tree structure. Okay, in tree if you can remember tree having depth, width, and everything. Okay, so depth means the number of levels in a tree. You know levels from root to the leaf node, the number of low levels in a tree, and width means the span. Okay, Uh, so width means the span. That means what is the maximum sub nodes of a particular node that is basically called the width of that. And fan out, we have already discussed that how many arrows are coming out from a particular module to the other modules, that is called fan out, and how many arrows are actually coming to a particular node, it's called fan in. Sorry, fan in. Okay, so the fan is indicates how many modules directly invoke a given module. So if arrows are reaching to a particular module and reaching to a particular module, say I'm trying to repeat these things. So this is a module, and there are many such arrows which are these are called fan in. Okay, that means inner arrow. Okay, if it is there, it means many other modules are actually using that thing. Okay, using that thing, invoking that particular module or invoking that functions inside that module. Okay, so that means if a module is being used by many other modules, then that is what we call it as a reuse of a code. Okay, code reusability. That means this module is so important that they are going to be used by many other what is called other models. So that represents reuse or reuse of the code. Okay, reuse of the code reusability. Okay, that is called code reusability, and it's normally they are encouraged. Okay, code encouraged because why it is encouraged? Because if your module is so general in nature, then and its purpose is so useful that many other modules are actually using this thing. So that means you are basically reducing the you are right code reuse means you are basically reducing the code length some because you have written in some code or function in such a way so that can be used by multiple other modules or you can say the functions of a module. Say for example, you say for M1 the fan out is 2, for M2 the I mean for M2 and M3 you see that's there are one fan in each, and M2 having fan out, how many fan out? 3 fan out, and M3 having 1 fan out. Okay, 1 fan out. So for M6, you see there are 2 fan in, okay, and no fan out, because these are the last module or leaf module, you can say. Now you see this is the node, this is the node, this is the node where there is a reusability. That means module M2 and module M3 are actually using M6. So that indicates that reusability. The two modules are using the same module. So that is called reusability. Reuse. Okay. So reusability, that M6 having reusability. Other modules do not have that reusability because almost all are being invoked by a particular what is called module, but only M6 having such importance that M2 and M3 both are actually calling that function or the module. So again we are coming to the goodness of a design. If, as I mentioned, that if a design having modules which having high fan out numbers is not a good design. Means fan out means this module M2. M2 having many fan out. Okay, that means M2 is dependent on M4, M5, and M6. Okay, so if any changes that need to be occur in any of the module M4 and M5, that again it will going to give a side effect or ripple effect to the module M2. Okay, so M3 you see it's only dependent on M6. So if there is any error occurring in M3, you have to check only the M6. So, but in case of M2, if there is an error, you don't know whether it's coming from M4, M5, or M6. So you have to check many number of modules. So that's why if the fan out, that means the dependent modules are more. That means this is not going to be considered as a very good design, because for any error cases and all, you have to check all the modules, which is really not considered as a good one. So your target should be something like that, that it should have less number of dependencies. Yes, there is no standard some kind of things which are there. Key these many fan out should be there, these many fan in should be there, but it should be as less as possible. Then it is far better. But all programs you're going to do it, you have to have some dependency into that. So we'll see later on some examples. And modules having high fan out, lack of cohesion also, like they are, since dependencies are more with the other modules, that means cohesions are more. I mean, dependency more means cohesion more means dependency more. So that means I mean, what will happen if that module or particular module is not independent? Then correcting, erasing, updating or changing a particular module is going to be very difficult. Okay, because as more a module is independent, okay, it is much more easier to correct that module. So I can give here example of that. Okay, I'll come into that later. So then in such same cases, as I mentioned, that if the fan out is very high, then it needs to invoke a large number of other modules. Okay, so it is likely that there are so many other the different functions need to be I mean, you have to implement. And if there are many number of functions you are taking the help for this kind of dependencies, it means that your task is not highly dedicated to a particular task. Okay, so that means it's not likely to perform a single cohesive function. Okay, single cohesive function means all are dedicated to perform a particular task. So if these grouping or set of functions which are there inside a module, if they're highly cohesive, highly dedicated, naturally they need a very less dependency to the other modules, because they become self-sufficient. Okay, those modules are self-sufficient. Yes, there are some cases that you may need to take the help of some other functions, which because due to reusability, because that functionality is say available in some other place, then in that case you may have to take. Otherwise, if it is there, then naturally you are depending much more on into that other modules. Okay, and then another concept which is there, that is called superordinate and subordinate. Okay, superordinate and subordinate. What is that? If a module is control another module, that is the boss module, then we call it as a supercoordinate. That means a module, if it sends some control message, say flag 0 or 1, then only the other will going to work. So in that case, what will happen? So that is called, that particular module is called the boss module or superordinate, and the other one which is actually dependent on some of the modules, like that for control signal, then we call it as a subordinate for that. So this is the thing that basically happening over there. So I can show you some background. Let's see. Now there is another concept that is called visibility. If it's a good design, there is something called visibility. What is that visibility? Say there is two module A and B. Okay? A and B. A and B. So if these two modules are some way connected, maybe A is invoking B or B is invoking A, it doesn't matter. Okay. So if A is invoking some way, if they're connected with each other, then we'll call that A is visible to B or B is visible to A. Okay. So if they all, I mean, call from there. So I mean, actually this is directly related to that. So you can say say A is calling B, so I can give a direction definitely. So I can give A or B. So since A is calling some function of B, then we will say that A is visible to B or visible by B. Or at the same time, if there is a module A, okay, A is calling C function, and then C is calling B, okay. So A is calling C, and then based on that A call is also calling B. Then we will say that A again is visible to B. Okay, so directly, whether it's a directly or indirectly, if it is calling, then we call that these two modules are visible with each other. Sorry. So the good design is something like that. In case of layering neat arrangement, okay, that module at a layer can call only the modules immediately below it. Okay, immediately below it. So I mean, it should not happen in the reverse. Is there a diagram? Yes. You see here, M2 can call immediate its one, that is M4, M5, M6, but M4 should not go back and call its superordinate. Okay, that is M2 is basically here the superordinate, because M2 is actually invoking M4, M5, and M6. So again, it should not go back in the tree upper side. Okay, so that is not going to be treated as a very good design. So these kind of back invocation, okay, are considered as a very bad design. Okay, it should not be in the layered structure. It should be as far as possible pre-structure. There should not be any cycle. Okay, there should not be any cycle that may form over there. And if it is there in the design, then it is called a bad design. Okay. Now another type of heat rearrangement, one is low fan out that we have seen, and another is abstraction. What is that abstraction is? That whatever lower level modules which are there, we have seen in this case, like M4, M4, M5, M6. Okay, they only do the input output. Okay, and the upper level lower layer, whatever it is there, they are basically the managerial task. That means the controlling task. So I can give you an example. Say it's something called like that. So this is your main, okay, the main function. Now there are some functions that you are calling. Say input. Input function. Then use prime. And then output. So what will happen? Main is basically the superordinate. Its job is to just control all the three the different subordinate models. So what it will do to find out whether a number is a prime or not, it will call a function called input. Then input's job is to read the value from the user, and then once it is there, it will return it back to main, that particular value. Okay, and then the main will take that value, okay, and then give it to a function called is prime. Then it will check and it will return one thing that is called what is called um, flag 1 or flag 0, okay, and then that flag it will return. And based on that, the purpose of the output function is to just check that flag value, whether 1 or 0, and accordingly it will going to print a appropriate message key the given number is prime or non-prime. So this see here, this particular main is performing the managerial activity. Okay, managerial activity, and these are basically just following the orders of the superordinates. So that is what actually happening in case of abstraction. Okay, lower level modules should do the input output or other small activities, and upper level modules should do the managerial activities. Okay, the lower level modules do not basically involve functions of higher level modules, because if it is like that, then there will be an arrow from lower level to the higher level. So that is not encouraged. And if it is like that, then we will say these are layered, because layerings are very clean. If you have a back arrow to some higher level, then you cannot say these are the good layered design. Okay, so that to be avoided. Now we know that what is high level design. We have already discussed high level design means modules and the relationship between them. Okay, so high level design, what it is doing, basically it maps functions into different modules. That means you are clubbing a set of functions inside a module. Now how you are clubbing, that depends, that will decide how good that design is, how strong the cohesivity is, how less low the coupling is. Okay, so that means you have you have decided a set of functions and how you are clubbing as a modules. Okay, so what that high level modules basically functions they are doing. So these what they're arranging those functions into different modules, say mi, fi, and mj. That say two modules. Okay, so each module it should have a high cohesion. Okay, and it should have a low coupling, and another is it should be layered arrangement. Okay, it should be layered, whatever that means. It's having low fan out, and should maintain a kind of an abstraction, whatever we have discussed. So that is what we call that a high level design, and it should be good design. Okay, so that means pictorially, if I say like that, you have a set of functions which are already say they are in the SRS document. From SRS document you can get this set of functions. Say there are n number of functions which are there. Now you are basically arranging them in the form of a, that means you group those functions into some modules such that, and you can find out that if you are grouping, then how the connectivity is going to be between these different modules, and what type of data which are actually passing from one module to the other module. Now there are two different approach Okay, there are two design approach. I mean, how you can design a software. Okay, how you can design a software. Uh, Function oriented design, these are relatively now old. Okay, the function oriented design, and another is the so far currently is going on, that is called object oriented design. Okay, most of the softwares are designed using object oriented design. As you know, that object oriented design having inbuilt that modularity things, I mean inbuilt feature over there, modularity. So, and it is easier to represent a real world scenario in the form of an object oriented design. Why and all that, you know, and we'll also discuss why object oriented design is good. But yes, of course, function oriented design is also necessary inside object oriented design. It's not like that object oriented design means you cannot have function oriented design. Inside object oriented design also you are going to have a function oriented design, because objects also need some functions, and whenever there is a function, you may need the help of function oriented design. So that means they are not basically complementary with each other. They are basically complementary, helping each other. They are not contradicting each other. That okay, function oriented is good, so sorry, object oriented good, so we're not going to use function oriented design. No, it is not something like that. Is basically complementing each other. That is the goodness of function oriented design is also be there in the object oriented. We need it, something like that. When we're going to see in detail, when you study function oriented design, we're going to see what is called data flow diagram and all that. Also we're going to take it in object oriented design also, though in your course, I don't know. Acha, during your object oriented paper, whether you have studied object modeling technique. Okay, then it's good. So what are the things that you have studied in that particular paper? What are the modeling technique you have studied? In Java it is fine. Now I'm talking about the modeling, the modeling, modeling during in object modeling technique. So what are the things that you have studied over there? Whether it, no. I'm not talking about that. They are the features of object-oriented programming. I'm talking about object modeling technique. Object modeling technique, basically, there are different modeling techniques are there, like Rombach model, Booch model. Okay, there are different people who have formulated this model. So let me tell you some name. I think you may remember. Class diagram, object diagram. Whether you have studied these things, class diagram, object diagram, then and another is functional diagram. There are three types of diagram which are there: class diagram, object diagram, and functional diagram. Whether you have studied these three things in object-oriented programming course, yes or no? Okay, fine. So now, okay, but actually, I don't know whether it is there in your syllabus or not. Mm, because object modeling technique itself is a different thing, interesting thing also, different thing also, from directly from the object related programming. So if time permits, I am going to discuss one of the latest object oriented modeling technique, that is called UML. Okay, unified modeling language. Okay, where you are going to study use case diagram, object diagram, sequential diagram, collaboration diagram, and I cannot remember exactly collaboration diagram, component diagram. We're not going to study of so many things, but at least something that we're going to learn, that is called what we call it as UML. Okay, Unified Modeling Language, and it's very popular in the industry. Okay, this is very popular in the industry, that is called UML, and there is a tool developed by IBM. Okay, that is called Rational Rows. Okay, Rational Rows. That tool actually drag and drop tool through which you can design these different what is called diagrams, and once you are able to design or draw the diagrams and everything for all the phases, at the end automatically it can generate C++ code, Java code, and that means the whole software is almost ready by that time. Only thing is that inside that function, you have to put the program on logic. That is the only thing that a coder need to do. Otherwise, the whole skeletal structure it's possible to generate through rational rules. So that's why it's very popular tool in the industry, also called computer-aided software engineering tool. So but anyway, we'll study those time permit. We'll study UML. At least I would like to introduce UML to you, at least few diagrams, because these diagrams are helpful for your project documentation also, because we normally ask the where is your use case diagram, where if it is a dynamic scenario, then it is going to be having sequence diagram and all. So we'll see. If time permits, I'll discuss this all those case to you. Anyway, now let's go to the function oriented design. We'll discuss in this later on, but just I'd like to introduce what is actually the function oriented design, what is object oriented design, and what is the difference between this function oriented design and object oriented design. Okay, so in case of function oriented design, as the name suggests, they are concentrating more on the functions. Okay, the main purpose is what are the functions. Okay, to build a system to software, they are concentrating on what are the functions, what are the inputs to be over there, what are the outputs from that function. So that is the main concern over there. Okay, and if you have some function call from one such function, so then that need to be taken care of over there. Okay, so that means it's concentrating only on set of functions. Okay, so each functions is basically you started with a very broad functions, and then you have to have a subdivide those things, or sub functions you may create it from there. Okay, so that refinement can be there. Okay, so and these functions are actually grouped into a particular module. Okay, as I am repeatedly telling that whatever SRS document we have seen, they are primarily matching with function oriented design, because in the requirement itself they write all the requirement in the form of a function itself. So that means the main idea over there is just to make to extract some set of functions from there. So that is the only thing. In case of function oriented design, you take a say functions function, and then you can create a sub functions for there. Okay, sub function from there, like main function I have shown you, and then that main function, or you can give it any name. Instead of main function, you can say check prime. Say check prime. So check prime having three sub functions: input, is prime, and output. Okay, so that means I'm just giving a very simple example. It's not that small, because their activity is very less. Input, for how many lines are there, is prime, how many lines are there, output, how many lines are there. But just to show some example, I'm just mentioning these things. He said you have a check prime is a function, managerial function, and you have three sub functions. So initially you would say that this is my function called check function. Now later on you can refine. You can say no, I cannot give a much load in a particular function. Let us subdivide that thing and make some sub functions from there. Accordingly, if you're going to refine, and all together you can put it in a single module. It's up to you. That you can put it. So one example, that create new library member. So this is a broad function. Create new library member. Okay. Now inside that you can have a more sub functions. What are those? Create the records for a new member. That means you are basically entering the new members. That is enrollment. Okay. You can say the new member. assigning unique membership number. This can be a subfunction. Prints bill, you can say, or you can say the print the card, membership card, or library card for the membership. So that means create new library member is a big function. Now what you can do, you can subdivide the task into some sub functions. Okay, and then what you can have a single module by putting all the functions: create record or enroll a number, generate membership number, print card, say for in your library, it's a print card. So these three functions you can club together in a module, but you have to decide first those four functions. Now, so as I mentioned, that's these basically library member functions can sub functions. Now, once it is done, then these functions need to be go into more detail. So that means divisions and relationship between those modules are the only high level design. Now once you are finalized with that, basically the lower level modules are the worker modules. Okay, that means they are actually performing some algorithms, they are actually running some algorithm, big algorithms. Computational task is more on those lower level modules. So what happens once you have, then you have to think about the what is the functions. Do you need more splitting of that or not, or you can just put it over there that actually code. So that way you have to arrange these things. And sometimes what happens in case of function oriented design, the approach may be centralized approach, like the central accessing of data, global data kind of thing. So if you are writing if you are writing what is called functions which are there, then many other modules may use that thing. Okay, many other functions may be use that thing. So say for say member record. So or what you can say that they are actually accessing a common data structure. Okay, say member records. Member record is a database, or member record is a record or structure, whatever you can do it like that. Then they all functions are actually using that thing. So available for reference separation to the several functions, create new member, delete member, update member record. They're all dependent on that particular common data structure that is called member records. Okay, so that approach is called the centralized approach, because data is in one place and there are many functions which are actually accessing that thing. That's data. So it may be part of that particular single module, it may be part of some other module also. Okay, so it depends on the design. There we have discussed earlier also there are different function-oriented designing approaches are available, and you see that whatever we are discussing that is structured design, they are called ordered design. Whatever rectangle we are drawing and the arrow that we are doing, these are called structured design or structured chart. It has been I mean I mean uh, proposed in 1979, long back. And then older than that, you order structure chart. You have Jackson structure chart that is in 1975, and then much more older is Wardier or methodology, rich stepwise refinement. Okay, there are a lot of methodologies which are there for functional design. So, but we will concentrate on structure design. Now let's come to the object-oriented design. In case of object-oriented design, it all not concentrating on the functions, it concentrating on the object. Okay, it concentrating on the object, or we call it as an entity, the real life entity. Object is nothing but a real life entity. Okay, that means some real life entities that you are actually trying to model or design in a computer. That what we call it an object. Because objects having many number of instances. Okay, objects are basically the instances anyway. That means you are creating many number of objectives of same time, objects of same time. Say if you have watch, so n number of watch can be created from there. So that is a different story. So you know from object-oriented programming. that object, what is actually object. But in object-oriented design, everything is design is around the objects and the relationship between their objects. And so objects is basically a package. Okay, it's a whole package. So it's itself is a object itself is a or class itself is a module. You see, class containing some data structure, data elements, and a set of functions which are actually operating on those um, data or variables or data structures. Okay, and usually what happens, those object oriented designs are decentralized. Okay, because they do not have direct access to some of the global data structure. Okay, like the way in case of functions, because functions are all open, any functions can call any data structure. So they are more centralized. But in this object oriented design, these are decentralized. So how these decentralized? Because say normally in object-oriented programming, global are discouraged. It's not used usually. So what happens? Say if data structure is available inside a particular. Say there is a object called stack. Okay, so you know. So now some other functions they need to take the help of. Now what happens? They cannot access the data structure, that array inside stack object stack. Okay, so I can, if you find it difficult, let me show you. So there is a module and there is another module. So this module is called stack. Okay. So there is a array. And one of those push and pop. Okay. Now some functions need the help of stack. So they what do they create a stack objects s1. Now what will happen? This s1 or any other functions, they take this s1. They will going to use this via these operations, the push or pop operations. You cannot have direct access to that particular structure. That's why this is decentralized. You can't get access to any variable directly. It must be via some member function of that particular object. Okay, which is not there in case of function-oriented programming, where functions are open, they can call, they can access any data structure over there. No restrictions. Okay, that's why people don't like function-oriented programming for a larger system, because these are the issues which are there. Now, say for a library automation software, in case of object-oriented design, in case of function-oriented design, you are going to find out all the lists: enroll member, print card, then delete member, calculate, renew the web. Okay, so these your main function-oriented program main task is to just identify those functions which is needed, and that can be done easily from SRS document. Okay, SRS document. But in case of object-oriented design, the design is something different. Here you have to think in terms of objects and the relationship between the objects. So what are those objects? Member can be an object. Okay, member can be an object. Then book can be an object, librarian can be an object. Okay, so these are the things that you have to identify. There may be more. I'm just telling you something that the book can be a member, librarian can be a member. What is called book? Sorry, the library member can be a sorry of the object. Sorry, I'm mistaking pronoun. Object member can be an object, librarian can be an object, book can be an object. Okay, so they will going to communicate with each other. Okay, how object oriented objects are communicating with each other? Do you know how objects are communicating with each other? What that method is called? Do you know that? How objects are communicating with each other? Hmm? Hello? Do you know what is the technique through which they are communicating with each other? Hello? Can you tell me? Do you know or not? बोलो हाँ भी नहीं बताते हो, ना भी नहीं बताते हो. That is the main problem. सोते रहते हो क्या? I don't know. हाँ तो हाँ, ना तो ना.
No, sir.
तो इतना टाइम लगता है क्या? So object, I mean, in case of object-oriented programming, objects are communicating through the method called message passing. Okay, they basically call the message passing. So message passing. I mean, message through message passing, they communicate each other. What is that message passing is? The message passing basically means, say in this case, the example that I had shown you. So this is an object called stack, okay? And this is another function, another object. Now, as I mentioned, that they need to access this array or stack. So they cannot use it directly. What they can do, they can simply call this functions. Normally call it as interface. Okay, they will call by passing a value x value, or oh sorry, not pop. What doesn't do that thing? Push. Sorry. Push. They will call that thing, that passing the variable x. So that will go here somewhere, that call means over here, and then up to its own constraint restrictions, whatever you are putting over there, then accordingly it will go through. So that means you are invoking a function by passing some values, okay, say x into that. So that is called, they're communicating these two objects. This is say object one, and object of a class, this is another object of a class. Okay, this is one. So they are communicating with each other by passing some message. Message means the data. Okay, that is, they are invoking these functions by passing the message. Okay, so that is called message passing. Okay, and me double s message passing. Okay, so that means it's very restrictive. You cannot have direct access to that data. So that is, it's very secure. Okay, very secure, because the objects are communicating with each other using message passing. Okay, is it clear to you? Is it clear to you? समझ में नहीं आता, you could ask, but I don't know. I mean, most of you always remain mum. Mum means either you cannot connect yourself with the things, which is very dangerous. Okay, which is very dangerous, or you may not be able to concentrate well into the whatever it has been discussed. So it's very important to have a connectivity connections during your class. So that actually shows. Otherwise, you have to do a lot of mug up kind of thing, and mug up will not going to help. At least in my case, you know very well. So that's why you have to keep yourself active during the class. It may be a kind of a theoretical, but there is nothing called theoretical. Everything which is happening in the industry, that is the thing we are actually discussing about here. Anyway, this is called basically the message passing. So in object-oriented programming, objects are communicating with each other via the method called message passing. Okay. So whatever I have discussed, you can now correlate with that. So objects have their own internal data like stack, okay, and state diagram. State diagram is also one diagram which is there in the object modeling technique. State transition diagram or state diagram. So that means one is class or object diagram, one is state transition diagram, another is your functional diagram. There are the three things which are there in the object modeling technique. So since you have not discussed, studied these things, so I'm avoiding these things. Similar objects constitute basically a class, that the actually thing is different. So that means a set of stack is going to be a stack class. A set of laptops can create a laptop class. A set of car can constitute a set of car object can constitute a class car. So it depends, different objects you are creating from a particular car class. So if there is a class called car, from there you can create objects like 800, Xylo, Wagoner. So any car you can create, okay, from the class called car, okay. But what is then missing, or some of the functions which are there will going to be remain common for all, that starting a car, stopping the car, light turn, left turn. So you can think of many functions which are commonly applicable to all of them, but they may vary from car to car object. They are different. The function same functions, but that means in 800 whatever it is there, Xylo it may not be there, Wagon are there, but the start function will be there, stop function will be there. But the start function inside may not be same in case of 800. The start function in Xylo may not be the same. The Wagoner start function may not be same, or stop function will be same. So that is the different thing. So the state diagram basically is that if you have a set of objects, similar objects, that you can normally plot it as a class. Okay, and each object in a member of object is a member of that particular class. Okay, so 800 is a member of that class car. Xylo is actually member of that class car. Wagon is member of that particular class or class car. Okay, and you know that class may inherit the features from superclass, subclass. You know very well. Okay, so the inheritance concept, polymorphism concept. Okay, and as I've mentioned that objects basically communicate with each other by the process called message passing. Okay, that is most important thing in case of object-oriented programming. That is called message passing. Now, object-oriented design are they don't go by the abstractions in terms of these functions like short, display, track. Okay, like this, if you can remember this diagram, that this is a superordinate model, and you have subordinate models. That is the way how function-oriented design they bring the what is called the abstraction. Okay, abstraction means that they basically do the I mean computational task, but high level or some superordinate they normally play the role of a managerial models. Okay, so object-oriented functions that don't do that thing. They try to create real world entities in the form of an object, like employee can be an object, picture can be an object, machine can be an object, car can be an object, computer can be an object. So that way they normally model. But here in this case of function oriented design, they concentrate on the functions. Short is a function, display is a function, track may be a function. So this way they are concentrated, object oriented not. Say in object-oriented modeling, software is not developed by designing those functions such as update, employee, update. This is a function. These are all functions. So these will be there definitely, but these will going to be not open. This will going to be part of, say, if, object called member, okay, or class called member. So inside that function is going to be there. It's not going to be remain open. It should be part of any object only. So update employee record, get employee address. So they should be more meaningful to be part of the functions of member object. Okay, you can create n number of object members. Okay, you can create n number of members from them. So object is basically the departments, employees. That way you can think of these things. Achha, you're right now you're studying what is called database, or you already have studied database?
सर अभी पढ़े सर.
Hmm? Now, abhi par rahe ho now,
Yes
already
sir.
done. So whether you have studied entity relationship diagram, entity relationship diagram, ER diagram.
Yes, sir.
So in entity relationship diagram, what happens that normally the real world entities are treated as entities and something that you can correlate with object oriented entities also. Okay, but there it shows the different entities which are there and the relationship between them. Okay. Achha, just tell me one thing. Tell me one thing. Since you are studying, uh, so it's a, let us assume you have to create a database for a university. Okay, for university. So university having different departments. Okay, different departments, and different departments having faculty. Okay, faculty and students. Okay. Now, can you tell me what are those entities over here? Hello, am I audible? Am I audible? University having departments, department having faculty and students. Say, this is the thing that you have to represent in the form of a database. Now, what are those entities? अरे क्या हुआ? हम लोग का प्रोसेसर बहुत ढीला हो गया. You are still using 8086 processor. बोलो. Yes or no? Can you able to do it or tell me or not? तुम लोग फर्स्ट ईयर में रहते इतना एक्टिव रहते हो डे बाय डे तुम लोग जितना भी हायर सेमेस्टर में जा रहे हो तुम लोग ढीला हो गए घर में बैठ के तुम लोग ज्यादा ढीला हो गए. See, these are the things which always should be active inside your brain because you don't know whenever you can get a call from any company, you know, for any interview. If it's really you're fortunate, then you're not going to get much time to prepare all those things. And how much you'll prepare? Those concepts should be very clear to you. That's why I have asked in extempo. Since you have studied ER diagram, so what are those entities? तुम लोग पढ़े हो कि नहीं पढ़े हो? तुम लोग कैसा हाँ भी नहीं बताते हो ना भी नहीं बताते हो. हेलो सुनाई दे रहा है और आई एम डिस्कनेक्टेड. हम्म. ओ अभी तो तुम लोगों ने बीसीए में नहीं पढ़ा. क्या पढ़ाई किया? डेटाबेस तो था. यू हैव ऑलरेडी स्टडीड डेटाबेस. पढ़ा कि नहीं पढ़ा था डेटाबेस? पढ़ा कि नहीं पढ़ा था? तो यह डायग्राम तो पहले यह डायग्राम तो पहले ही होता है. और तुम लोग बुक भी नहीं खरीदते हो. तुम लोग वीडियो लेक्चर्स भी नहीं देखते हो. दीज आर सो इम्पोर्टेंट पेपर. Whenever you try to appear for any exam, any interview, these things are very important. You are just waiting that someone will going to deliver something, then you will just confine yourself within that lecture. And if you can able to understand, it's fine because your target is just to pass the exam. score in that exam. That is the only thing, not to learn. Your target is very limited, only just to do these things. Just tell me how. I have shared a book with you, Rajiv Mall book. I have shared the lecture series by Professor Rajiv Mall. How many of you have gone through that? बोलो तो कितने ने उसके अंदर से गया है कि जो मैंने पढ़ा दिया है तुम लोग उसको एक बार देख लिया वहां से कितना कितना ने किया है बोलो तो क्योंकि मैं इस बार ये सेमेस्टर में सोचा था कि आई एम नॉट गोइंग टू वेस्ट मच टाइम डूइंग दिस साइड लेक्चर्स क्योंकि यू ऑब्जर्व दैट अर्लियर आई यूज्ड टू गिव मच डिस्कशंस ऑन दिस थिंग्स की क्या होना चाहिए तुमको मोटिवेट करने के लिए आई थॉट यू आर मे बी हाईली मोटिवेटेड बाय दैट टाइम सीनियर बन चुके हो लेकिन तुम लोग तो अभी जैसे कि वैसे ही रह गए हो हाँ जैसे कि वैसे ही रह गए हो बिकॉज यू आर कंसंट्रेटिंग मोर ऑन द एग्जामिनेशन कि जब एग्जाम आएगा देख लेंगे कितने ने देखा बोलो तो लेक्चर किसने देखा बोलो जो मैंने शेयर किया था किसी ने देखा हाँ वही तो प्रोफेसर राजीव मॉल का तो मैंने शेयर किया था ना सीरीज ऑफ लेक्चर्स हाँ तो और कितने ने देखा बाकी लोगों ने देखा बाकी लोगों ने देखा वही तो प्रॉब्लम है ना तुम लोग कभी कभी सोचते हो कि डिपार्टमेंट में आने से क्लास होगा नहीं तो नहीं होगा अरे बाबा सीरियसनेस अगर होना चाहिए तो घर में बैठ भी होगा गेटिंग रेडीमेड फूड बाकी कोई टेंशन नहीं होता घर का काम होता है और whenever you come back at least you attend the lectures और lectures भी arbitrary टाइम में होता है it's not that it's following all throughout the day तो जो जब टाइम होता है you should go through those lectures database पढ़ रहे हो why to wait for someone's lecture you have enough YouTube materials or forget about materials you have already started during BCA so you should able to tell these things ना कि क्या चीज है ये डायग्राम है ना very pathetic condition you have वेरी पैथेटिक कंडीशन मतलब ये वो कोई कोई तो ऐसा होता है ना कि टू गेट अटेंडेंस कहीं से भी ऑनलाइन हो जाओ क्लास का टाइम में तुम दूसरा काम करते रहो कोई कोई कौन देखता है देखो यू आर नॉट इन द स्कूल ट्राई टू अंडरस्टैंड यू आर नॉट ए किड कि कोई तुमको गाली देगा पीटेगा मारेगा एंड देन यू ओनली गोइंग टू बी वेरी सीरियस दिस इज योर लास्ट अपॉर्चुनिटी आई टोल्ड सेवरल टाइम्स ट्राई टू बी मच मोर सीरियस इनटू दैट लेकिन यही चीज बाद में तुमको रियलाइज होगा अगर अभी तक रियलाइज नहीं हो रहा है तो जो द थिंग दैट यू आर शोइंग इन टर्म्स ऑफ योर सीरियसनेस कोई भी सब्जेक्ट हो अच्छा हो बुरा हो हार्डली मैटर्स व्हाट इज मैटर इज दैट सेल्फ लर्निंग कैपेबिलिटी वो सबसे बड़ा इंपॉर्टेंट चीज होता है जो अभी न्यू एजुकेशन पॉलिसी में भी वो ज्यादा दिया गया है इंपॉर्टेंस क्योंकि मैक्सिमम इंडियन स्टूडेंट का प्रॉब्लम है दे आर लैकिंग ऑफ इनोवेशन वो सोच ही नहीं पाता है क्योंकि उसका कंसंट्रेशन सबसे ज्यादा है एग्जाम में क्लियर करना और कुछ नहीं है और यहाँ पे भी तुम लोग क्या करते हो जो पढ़ा दिया टीचर ने उससे ज्यादा कुछ पढ़ेंगे ही नहीं सीधा बात है जरूरत क्या है क्योंकि तुमको तो स्कोर करना है लेकिन स्कोर का मतलब क्या है आई हैव ऑलरेडी इंटरेक्टेड विद डिफरेंट इंडस्ट्री पीपल तो प्रॉब्लम इज लाइंग ओवर देयर इटसेल्फ क्योंकि दे आर लुकिंग फॉर गुड कैंडिडेट लेकिन दे आर नॉट मोटिवेटेड कितना स्टूडेंट मैंने पूछा था एक वन थिंग कि हाउ मेनी ऑफ यू आर कॉन्फिडेंट इन सी प्लस प्लस तुम लोग पढ़ के आ चुके हो तो तुम लोग का सी प्लस प्लस था कि नहीं पहले बोलो तो तुम लोग का सी प्लस प्लस था कि नहीं
No, sir.
हाँ यस और नो
No, sir.
तो मैंने जब पूछा कि कितना कितना तुम लोग सी प्लस में तुम लोग ये हो कितने ने तुम लोगों ने रिप्लाई किया एक को छोड़ के किसी ने भी रिप्लाई नहीं किया किसी ने भी नहीं रिप्लाई किया नाइदर फ्रॉम योर बैच नॉट फ्रॉम योर सीनियर बैच तो इसका मतलब क्या है तुम लोग कुछ नहीं जानते हो और फिर इंडस्ट्री हैविंग लॉट ऑफ अपॉर्चुनिटीज फॉर ए गुड स्किल स्टूडेंट राम whether they have contacted you हाँ तो क्या बताया एग्जाम दिया तो ठीक है, ये इट्स अप टू यू। अब ये तुम्हारे ऊपर बात है कि हाउ यू कैन क्लिक इट। उसको अगर क्लिक कर सकते हो तो यू आर एक्चुअली मेकिंग ए पाथ टू दैट इंडस्ट्री। सिक्किम यूनिवर्सिटी में बैठ के, इतना कॉर्नर में बैठ के एक अपॉर्चुनिटी मिलना, इट्स ए बिग थिंग। तुम लोग का सीनियर और एक है निखिल, उसको एक इनपुट टेस्ट करके वो कंपनी में उसको मिल भी गया। दे विल गोइंग टू स्टार्टिंग सैलरी गोइंग टू बी 6 लाख पर एनम। स्टार्टिंग है, मिल जाएगा, बाद में बढ़ जाएगा। और एक सीनियर को चांसेस है कि दे ही मे एबल टू ऑब्जर्व इन अनदर मल्टीनेशनल कंपनी। कहां से मिल रहा है? थोड़ा ही हो रहा है, वो तो अपना स्किल से मिल रहा है, थोड़ा ही ये होता है। यू पीपल आर नॉट विलिंग टू लर्न एनीथिंग। है ही नहीं तुम लोग का बॉडी लैंग्वेज, अरे मुझे पता नहीं है, होता नहीं। अभी प्रोजेक्ट रहेगा नेक्स्ट सेमेस्टर, आई एम श्योर देयर विल बी वन मेंबर हु विल गोइंग टू वर्क, उसमें तुम कुछ सीखोगे, दैट इज आल्सो ट्रू। कि कोई इंडिपेंडेंट बनोगे, प्रॉब्लम आएगा, देन यू विल लर्न। और बाकी जो लोग रहेगा उन लोग डब्बा जैसा उसके ऊपर डिपेंडेंट पैरासाइट होके घूमता रहोगे कि भाई वो तो कर रहा है, मुझे क्या सीखना है। सो दैट इज द वर्स्ट पार्ट। मैं वही सबसे बुरा लगता है। अरे व्हेनेवर यू डू, यू शुड डिस्ट्रीब्यूट योर वर्क। कि अगर वो कर सकता तो मैं क्यों नहीं कर पाऊंगा। यू डू योर वर्क, यू डिवाइड इट इनटू सम मॉड्यूल्स एंड देन डू पैरेलली, यू डू रन दिस थिंग्स, डिस्कस अमंग योरसेल्फ टुगेदर। वो करके देगा और तुम लोग बैठ के प्रेजेंटेशन दोगे, हाँ ये 2-3 स्लाइड तुम बोलो, ये स्लाइड तुम बोलो। आइडिया नहीं होता अंदर में क्या हो रहा है, तो हु विल बी द लूजर? जो काम नहीं करेगा, जो अपने आप को डर के मारे पीछे रखेगा, he will going to or she will going to be the loser। कि मुझे प्रोग्रामिंग नहीं आता। अरे नहीं आता है तो क्या होगा, सीखना पड़ेगा। अगर पहले से डरोगे तो कैसे होगा? अगर पहले से तुम लोगों ने डर गया कि यार मुझसे तो नहीं होगा, ये लास्ट अपॉर्चुनिटी भी हाथ से चला गया और नहीं होगा। और तुम लोग का ऐसा हालत है कि बीसीएम की तो गारंटेड है, तुम लोग ने ये डायग्राम पढ़ा था कि नहीं? बोलो तो ये डायग्राम बीसीएम में या बीएससी में, जो भी मतलब जो कोर्स पढ़ा है, पढ़े थे कि नहीं? ये डायग्राम पहले पढ़े थे कि नहीं? बोलो।
यस सर।
हाँ, तो तुम लोग क्यों आंसर नहीं दे पाते हो? यू नीड रिविजन करो। एमसीए में क्या है? एमसीए में तो जो पढ़ गए उससे थोड़ा माइनर एक्सटेंशन हो सकता है, या सेम थिंग यू हैव टू रिपीट। मतलब तुम लोग बीसीए में नहीं सीरियस नहीं, तो कैसे क्या करूं बोलो? इसलिए मैंने आज नॉक करके देखा कि तुम लोग सोते रहते हो क्या। वेरी गुड। ये सब होने से तो कुछ भी सब्जेक्ट नहीं होगा। मार्कअप करके ऑनलाइन है, उसका फायदा ले रहे हो, व्हाट्सएप ग्रुप बना लिया, एक देख कर रहा है, दूसरा को शेयर कर रहे हो, उसमें बैठ के आराम से लिख रहे हो। तो ऐसे ही चल रहा है तुम लोगों का। हु नोस, ऑनलाइन ऑफलाइन एग्जाम हो जाए, क्योंकि जिस तरह का अभी ड्राइव चल रहा है, सिग्नेचर ये खोलना है, तो हम लोग के लिए तो अच्छा ही है। एग्जाम हम लोग हो जाएगा ऑफलाइन, ऑफलाइन होने से तुम लोगों का हालत खराब हो जाएगा, क्योंकि यार मत डिपेंडेंट ना ऑन बुक, कि बुक में अंदर है वो निकल जाएगा। लेकिन मेरा सब्जेक्ट इज समथिंग डिफरेंट, यू नो वेरी वेल। मेरा सब्जेक्ट में नॉर्मली इस तरह से बुक खोल के लिखना या बुक से डायरेक्टली आंसर मिलेगा नहीं यूजुअली। ठीक है, सो बी रेडी, बी प्रिपेयर फॉर दैट। So now Grady Butch is one of the very famous person who designed that, basically that object oriented modeling. There is one more person, Romba. Okay, and there is one Grady Butch and Romba. They have their own style of object oriented modeling, and then later on they come up together. And then they created that modeling technique that is called UML, or Unified Modeling Language. They later on come Grady Butch, Rombard, and one more person. I think there are three persons. I can't recall who is that third person. The three persons, they merge their all three designs and then come up with what is called UML. That from there itself that name has come unified. That means they have club all their design into a one that is called Unified Modeling Language. So now, in case of function-oriented design, since they are considering on procedures or functions, that means they are more in a sentence. They are more considering on the verbs. Because verb means some activities which is going on. Okay, but in case of object oriented design, they are concentrating on nouns. Okay, say employee, say student, say department, okay, say who. So they are basically all noun. So if you are designed based on those nouns in a system, then that is called object oriented design. Then it you can consider that actually object oriented design can be done over there. But if you are considering more on the activities or functions and all, that is verb. Okay, then that is called procedural design. Like is prime. Is prime is a verb. Am I right? So that means it's basically a procedure or a function. Okay. So in case of object-oriented design, uh, state of that object is their state. What is that state? If time permits, I will discuss later on that what is the state information or what is the state of a particular object. Okay, that I'll do these things later on. Okay, say it's okay. Switch. Say switch is an object. Just simply I'm giving an example. Say switch is an object. Okay. Now there are two states: on state and off state. If you are switching on, then it is in on state, and if it is off, then it is in off state. There are two states which is there in the switch. So there are some examples. I'll if time permits, I'll discuss that. So this particular state information. So in which state an object is, it's not going to be shared a centralized way, because it is completely decentralized system. But this is what is happening. It's distributed among the objects. Say stack having a particular state. So that is only confined within that particular stack object only. It cannot be accessed directly by other objects. Okay, because they communicate with each other through message passing. So say let us take one example. Say employee payroll system. Okay, so what are those global data that are going to be accessed by multiple functions? Name of the employee, their code number, their basic salary. Okay, whereas in case of object-oriented system, what will happen? These data are going to be concentrated within employee object. Okay, so employee, name of that employee, code of that member, salary of the basic salary of that, these things, it will going to be part of a particular object, employee 1, employee 2, employee 3, or something like that. It cannot be accessed by other. So employee 1's data for member, card, code number, employee, basic salary cannot be accessed by the other object. Okay, so that is distributed. These are decentralized. Okay, but in case of the procedural program, it will be there in a common place. Okay, it will be there in a structure. So there are for 5 employees, there are 5 different record. Okay, and anyone can go and anyone can access. But in case of object-oriented programming, this is distributed. It means anyone, I mean, if he wants to access the values of the object 1 or employee 1, they need to do this thing through message passing. If it is already there inside there, directly you cannot get that. Directly cannot access their data. So that way it's really highly secure. Okay. So since it is communicating through message passing, as I mentioned, so one object may discover the state information of one subject to the other object by asking questions. Can you give me the details? So if there is any functions in one employee, then only you can get that you can pass it to the other object for that. So that is what actually called the message passing way of communicating over there. Okay. But of course, you need to do some functions oriented modeling also, because ultimately you have functions, but it should be within that object. Okay, within that object, how they are communicating each other. We will see with some example later on when we study in details. Okay, and functional techniques is only concentrating on set of functions. Okay, and you can club it and you can make it a module over there. Okay, but on object-oriented technique, functions are grouped along with the data. Okay, based on that data. Say employee. employee data will going to be there, and the set of functions will be designed based on that how to access the data, how to access those data. That is the main concentration of it. Okay, don't worry, we'll discuss in details again when we'll study object oriented design and all. Okay, now say let us assume one example that is called automated fire alarm system for a large building. Say this is a software that need to be created. Okay, automated fire alarm system for a large building. Now what are the case studies which is there, what is the system is. Okay, there are 80 floors which are there in that building. Okay, and there are 1000 rooms in the building. Okay, 80 floors and 1000 rooms. Okay, so that is the scenario. Now what happens, different rooms of the building is fitted with a smoke detectors or fire alarms. Okay, now what it will happen, the fire alarm system will going to monitor that this smoke detector or fire alarm detectors. Okay, now whenever some cases happen for fire breakout and something like that, then that smoke detector will going to send that information to the centralized fire alarm system, and then fire alarm systems will going to automatically decide from where that signal is coming, and then it generates a warning or alarm to the building or to the fire brigade or whosoever is there in the neighboring rooms of that particular target rooms affected. So, as I've said, that firefighting personnel can be sent some message and all through this. Now, once that fire condition has been successfully handled, like you have done everything, um, so what will happen? It will go into the fire alarm will going to be stopped. Okay, in case of stop, and the whole thing will go come back to the original state. Earlier state was something different. Now early alert state. Now it comes to the normal state. So this is the task of the target software that we'd like to develop for a fire alarm system. Now, in case of function-oriented approach, they, as I mentioned, they are only concentrating on some data and some functions. Okay, so what will be there? That to keep track of thousands such uh, detectors, you have a variable array called detector status. So it's an array of 1000. So each cell of that array indicates which detector is on or off. So if in initial case all are say 0, it means no detectors are on. But if some detectors are on, it will going to be 1. So looking into that, you can easily understand which smoke detectors actually detecting that fire. Okay, and then another one say detector location. Okay, detector location, you can have the different locations looking into that. Bully from detector status also you can do these things, but if you can have another separate locations, because there are 80 buildings, so in that way also you can do these things. Okay, then alarm status, that also you can detect the status. That means there are two, I mean alarm, whether you are switching on that alarm or not, that also you can keep a status by using this boolean variable 0 or 1. Okay, and then alarm location for where you have located that alarm, that also you can do this thing, which alarms you have on, because for entire building you no need to be start your alarm, it should be the nearby these things. Okay. And then what are the functions which are need to be there? Checking the detectors, get the location of the detector, determine the who are the neighbors of that particular location, ring the alarm, reset the alarm, report fire location. So these are the functions that you can list out. Okay, that some set of data, common data, globally accessible, and these are the functions which will be there in case of function-oriented approach. But in case of object-oriented approach, what will do? You will going to model system in the form of an entities. So detector can be an entities, alarm can be an entities, and what are those attributes or data which will be there inside that? The status of the detector, location of the detector, neighbors of the detector. What are the operations? Create detector, sense the status, get the location of the detector, and find the neighbors. Okay? These are the functions which are concentrating on the attributes or the data which are there inside class detector. Similarly, for the alarm, you may have location of the alarm, status of the alarm. It's on or off. And operations: create the alarm, ring the alarm, get the location of that alarm, and the reset that alarm. So these are the functions which are concentrating only on those data called location and status. Okay, the location and status, and these are different functions which are there inside. Okay, so if you have 1,000 detectors, you are going to create 1,000 instances or 1,000 objects. If you have 1,000 alarms, you will create 1,000 alarms. No issue, no problem. Very easy to do that thing. Okay, you just create a variable or object of that particular class. That's all. Okay, no need to do this boolean variable array or something like that. So in the function-oriented program, the system state is centralized, as I have mentioned, because they are working on the same set of global variables. Okay, and then several functions are basically accessing centralized way to those global one. But object-oriented, they are completely distributed, decentralized, because they are going to be part of a particular object, not available openly. Okay, then there is something called top-down approach and bottom-up approach. Whatever you have discussed, that at the very beginning you have big module, then you are refining it to the sub modules, and then you can go on refining. So this is what we call it the top-down approach, starting from top to the bottom. And bottom-up approach means you are taking a small modules, club it together into a bigger module, then some similar such kind of club modules can be again clubbed, and accordingly it can go to the towards the root of a particular tree. So that is the bottom up. Starting from bottom, it goes to the top. So that is called bottom up approach, and another is called top down approach. So top down function oriented, it follows the function oriented design, basically follow the top one, because they started with a function and then you subdivide or create some sub functions from there. Okay, um, and what is happening in case of object oriented, it is basically, I mean, normally it's an open bottom up, because you have a different, say, similar set of objects, and that you can club it into a class. Okay, so that you can go ahead using this. So but in each class there is a small hierarchy of functions to be designed for a top down manner. So that means inside the class itself you have a set of functions that you need to design in the form of a function-oriented way. So that means you are not completely neglecting function-oriented design in case of object-oriented design. They are actually complementary with each other. Anyway, so let us summarize these things for today, the overall class of design. So we have started with different software design phase that we have done. Then what need to be produced at the end of the design phase, you know, the high level design and the low level design, then what is called fan in, fan out, cohesion, coupling, abstraction. These we have studied in these sections. Okay, and then what is how to decide the cohesion and coupling in a modular design, that we have studied. Then also we have, lastly today we have discussed about function oriented approach and object oriented approach that we have used. So we also have seen that they are actually complementing with each other, they are not contradicting. Okay, and then in the next class we're going to study in details how to do this function oriented design. What are those diagrammatic tools and everything like DFD and all. This is most important, DFD and all, how to draw and everything. And then if possible we'll try to take some example problem, and then we would like to solve those problem in the form of a DFD. Okay, so do you have any queries, anything, any doubt? Any doubt, any query?
Yes, sir.
Okay, in between who left? Anita. Anita is not there. It's a problem. You are just to keep yourself safe somewhere in terms of attendance and all. You are attending, and then with an excuse or network issue or something like that. You usually leave. Anyway, you are mature, quite mature student. You are master degree students. No need to motivate you much. You know what is your uh, need, what is your requirement. Rest is up to you. Anyway, so so next Tuesday we have our examination. Okay, if you can remember, and then I'll declare the what is when I'm going to be our next class. Okay, see you on Tuesday. I'll tell you the timing. Hopefully in the morning half. Otherwise in the evening I'll do that. Okay.
Sir,
Yes. Syllabus?
sir, evening,
No, evening? What is evening?
yes, sir. Morning में सर मेरा दूसरा एग्जाम है सर.
Oh, so then we will go for the evening, same 4 o'clock.
Okay, sir.
Okay?
Okay, sir.
See.